So what you're going to find is that if you ever want to divide using long division, and when it comes to polynomials, it is a pain. I mean, let's be honest, long division is kind of a pain just dividing any two numbers. So fortunately, we have synthetic division to help us along with that. Now, one of the things I want to point out is when we're dividing with synthetic division, we do not use the factor that we're dividing by. We use its zero. To do this, we need to ensure that we include all coefficients, whether they're written or not, of our polynomial. So I see I have the third degree, second degree, first degree, and if I wanted to write it in, even the 0 degree. Now to set this up, we just draw kind of an upside down division sign, and we have our 0 up here, and then we have our coefficients right here. So now that we're dividing, first off, I want to point out that this is a third degree polynomial. So this top line here is a third degree, and we're going to divide that by a first degree polynomial. Well, based off my exponent rules that I should be pretty comfortable with now, if I take x cubed and divide it by x to the first, that's just going to be x to the 3 minus 1, or x squared. So it's going to decrease the degree of my polynomial by 1. So down here is going to be a second degree polynomial. It's just an important detail for later once we start using this to find the zeros of our polynomial functions. The division here is actually pretty straightforward. So we just are going to take the 5 and drop it down here, okay? And then I multiply -2 times 5. That gives me -10. I add those up and I get -16. I do the same thing here. -2 times -16 is positive 32. Add those up and I get 4. And lastly, I multiply the 2 times the 4 and I get -8, which is going to give me -10 when I add up -2 and -8. Well, like I said, this is a second degree polynomial, so since the 5 is the leading term here, I know it's going to be 5x squared minus 16x plus 4, and then, oh, that -10, that must be my remainder. And of course, we can write out the remainder as just adding -10 over our divisor, or that factor that we were dividing by, x plus 2. And that is how you can divide using synthetic division. Pretty clean, pretty simple. Again, the things to keep in mind are that the degree you have here is very important, and keeping track of what degree your next step will have. In general, you should always be actually, I don't even think it's in general. Always with this method, you're just going to be decreasing it by 1 after each step.